Ever wondered how neural networks learn? Today, we dive into the intriguing world of artificial intelligence to answer just that. At the core of this exploration, we find neural networks. These marvels of technology are inspired by the intricate workings of the human brain, and just like our brains, they absorb, process, and learn from information. But how does this happen? Well, that's where our key concepts come into play. Feedforward, backpropagation, convolutional neural networks, or CNNs, and recurrent neural networks, or RNNs. Feedforward and backpropagation are the basic mechanisms by which a neural network learns. CNNs, on the other hand, are designed to process data with a grid-like topology. Think images. RNNs are used when there's a need for memory of previous inputs in the network, like when processing a sentence. Now that we've set the stage, it's time to delve deeper into how these networks function. Feedforward and backpropagation are the heart and soul of neural networks. But what exactly are they? Imagine a game of telephone, where a message is passed along a line of participants. This is similar to feedforward in neural networks, where inputs are passed through the network to generate an output. Each player, or node, in the network has a specific role in transforming the input, which ultimately shapes the final output. Now, imagine if our game of telephone had a system to correct errors. If the final message doesn't match the original, we could tweak the message at each player to get a closer match next time. This is akin to backpropagation, where the network learns by adjusting the weights of each node based on the error in the output. So, if we think of feedforward as the process of asking a question, backpropagation is the method by which we refine and perfect the answer. In essence, feedforward is the question, and backpropagation is the answer. Moving on, let's chat about convolutional neural networks, or CNNs for short. These are a special breed of neural networks designed specifically for processing images. You see, images are more than just a collection of pixels. They carry a spatial relationship, meaning the arrangement of pixels has meaning. A CNN recognizes this and uses it to its advantage in image processing. Now imagine a grid of pixels as a city, and each pixel is a building. Regular neural networks would just see a list of buildings, but a CNN sees an entire cityscape. It understands the neighborhoods of pixels, their arrangements, and their interactions, preserving these spatial relationships. The CNN applies filters, similar to how we use filters on our photos, to identify features like edges, textures, or shapes. By stacking these layers of filters, the CNN can recognize complex patterns, essentially giving computers the ability to see. CNNs, in a nutshell, give computers the power to see. Last, but certainly not least, let's talk about recurrent neural networks, or RNNs. Picture RNNs as a unique type of neural network, designed with a special knack for processing sequences of data. This makes them the perfect candidate for tasks like language translation and speech recognition. Through their sequential data processing ability, they can grasp patterns over time and context in a way other networks can't. This gives the RNNs a distinctive edge, a kind of memory. RNNs essentially provide machines with a memory. So there you have it, a quick journey into the world of neural networks. We've delved into the fundamental processes of feedforward and backpropagation, explored how convolutional neural networks serve as the eyes of AI, and dived into the memory capabilities of recurrent neural networks. These layers of complexity enable the fascinating world of AI to function and evolve. Remember to subscribe to Tech Trailblazer, share this video with your friends, and hit the like button if you found this information useful. Until next time, keep blazing tech trails.